Use the definition to find the derivative of f of x equals 1 over the square root of x. Then evaluate f prime of 9. The first thing to do is to write down the definition of the derivative. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all divided by h. The next thing to do is to formulate f of x plus h. That means to take f of x, 1 over the square root of x, and replace each x with an x plus h in parentheses, 1 over the square root of x plus h. Then we're going to subtract from that f of x, which is 1 over the square root of x, and all of that is divided by h. We have the 0 over 0 indeterminate form, and we will continue to have that until we can factor an h out of the numerator to cancel with the h in the denominator. We have no ability to do that right now, but what we do have is a subtraction of fractions in the numerator. We will need to combine those together through a common denominator. So that is going to be our next step, is to form the common denominator between those fractions. We have a denominator of root of x plus h and a denominator of root x. The common denominator will be the two multiplying each other. So we will have limit as h goes to 0 of, let's take the 1 over square root of x plus h, which we don't need parentheses for that x plus h any longer, and we're going to multiply it by root x over root x, a form of 1, to get the common denominator, minus 1 over root x, which we're going to multiply by root x plus h over root x plus h, and all of this is divided by h. So we have the limit as h goes to 0 of multiplying the first fractions in the numerator. 1 times root x is root x over root of x plus h times root of x. Since they're both under a root, they can go under the same root. They are multiplying each other. So root of x times x plus h minus 1 times the root of x plus h all over root x times root of x plus h, which can become a single root with the two multiplying each other. Our next step is to combine those fractions together. They are subtracting, so we subtract the numerator all over that common denominator. At this point, we have a fraction in the numerator, and we're going to take the fraction in the denominator, which is currently not a fraction, it's an h. Let's turn it into a fraction by putting over 1, because we're going to reciprocate and multiply. That's always your next step after a common denominator. And that will give us limit as h goes to 0 of root x minus the root of x plus h divided by root of x times x plus h. All of this is going to be multiplied by the reciprocal, which is 1 over h. We can now multiply those, the numerators, root x minus root of x plus h times a 1. Doesn't change it. In the denominator, we have an h times that root. I'll write the h first. Times the root. The h is not in a root and will not move under the root. Our goal is to get that h in the denominator to cancel with an h that will factor in the numerator. We still have 0 over 0, and we don't have an h to factor from the numerator just yet, but what we do have is a root combination, a root involving the variable h, it's h going to 0 here, It involves h in some way added or subtracted together with at least one other term. That's happening in the numerator. We can form the conjugate of that root and multiply it. It's the root conjugate method. The conjugate will be the same expression but opposite sign. So it'll be a plus. And we're going to put this over itself. And we're now going to multiply by that form of 1. So we don't change the value, just the look. And that will give us limit is h goes to 0 of. The numerator are root conjugates, so we're going to FOIL that out. First, root x times root x is an x. Outside, root x times a root of x plus h becomes a positive root of x times x plus h. Inside, negative root of x plus h times root of x will be a negative root of x times x plus h. And then last, we have a negative root of x plus h times a positive root of x plus h, which will be a negative of the quantity, be sure to put parentheses around it, of x plus h. That negative will need to distribute onto both of those terms. In the denominator, we have h times root of x times x plus h and then times root x plus root x plus h. We're not going to FOIL or distribute in any way. We want to keep this factored, since those are not root conjugates. The outside and inside terms after root FOILing are always equal value, opposite sign. We can cancel those out. You don't even have to write them necessarily. I show them so that you can see they're canceling. Limit is h goes to 0 of, in the numerator, x, and then we have a negative to distribute, negative x, negative h, all over that denominator. There's a positive x and a negative x in the numerator that will cancel. So let's cancel those out. And at that point, we actually have the ability to cancel the h left in the single term in the numerator with the h in the denominator. As soon as we cancel that h in the denominator, we have removed the 0 over 0 indeterminate form. That's always our goal. So I'm just writing our denominator exactly as we see it. So they can now cancel these h's out. That'll leave a negative 1 in the numerator. We no longer have the 0 over 0 indeterminate form, which means we now can plug in 0 into all remaining h's. And that's going to be our next step, which will give us our derivative. If I put a 0 into the remaining h's, I will have a negative 1 over the square root of x times an x plus a 0, which is just an x. All of that times the square root of x plus the square root of x plus a 0, which is just an x. So I have a negative 1 over the square root of x squared times square root of x plus square root of x, which is 2 square roots of x. The square root of x squared is an x times 2 root of x. What I'm going to do is write that square root of x as an x to the 1/2. And the reason I'm going to do that is I need to combine those x's together. So this is going to be an x times 2 times x to the 1/2. The 2 can be put out front, and I'm going to have an x to the 1 and an x to the 1/2. You can combine those by adding the exponents, 1 plus 1/2. So we have -1 divided by 2x to the 2/2, that's what 1 is when put over 2, plus 1/2, or -1 over 2x to the 3/2. There's the derivative. The next thing to do is evaluate f prime of 9. Now let's do that. That'll give us -1 over 2 times 9 to the 3/2. Raised to the 3/2, what that means is the denominator of the fraction 3/2 is the root, and the numerator is the power. It's usually easier to do the root first, then the power, but you can actually go in either order. So I'm going to take the square root of the 9, because the 3/2 is a square root for the halves. The square root of 9, which is a 3, and then cube that. Alternatively, you can cube the 9 first, which is a really big number, and then try to figure out the square root of that big number. You'll get the same answer either way. This is the easier route. 3 cubed is 27. -1 over 2 times 27 will give us -1 over 54.